Okay, I started working on the heads, the cylinder heads, and plus I made the head bolt studs, or the, well, yeah, they're head bolt studs. So anyway, here's what I got. I'm going to move you over here by the surface plate. And try to move it down a little bit. Oh, elevator down. Alright. So here's what I've got. I took and I roughed out the heads. I mean, there's finished. The whole pattern is a finished whole pattern, but it's, you know, it's I classify it as roughed out. But I got the whole pattern in for mounting, and then I've got the valve ports in. One side is you definitely don't want to deburr it because that's going to get lapped with the valve. And this is 7075, again, T651. I got lots of blocks of this stuff, so that's what I'm going to use. So they are basically ready to put the exhaust port and intake ports in. And what I did was I made a little holding fixture here that these will mount on. And they mount on a certain way to keep them orientated right. I have a little mark in the corner right there, and a little mark in this corner. That's because that's the way it goes on. And they fit snug, so there's no, once you get them on, there's no shake in them. And I'll put screws in, I'll bolt it in place. But what I need to do now is I need to put in a tooling hole here for a tooling ball on both sides. That way I'll have a known dimension from this corner here, so it'll be over, and then from there, well, from there down I already know, so it'll be over, and then from the top surface down, and I'll put that in at a known dimension. And what I'll do is I'll take a tooling ball, and what this is, a tooling ball, and the exact distance from here up is 312, and the diameter is half inch. But anyway, that goes in there, so I know the dimension out to the center of that sphere, of that tooling ball, so that when I set this up, and I'll know where that's at, because I'll use my CAD to get a dimension from there up to where that hole goes in, where that port hole goes in. That'll get me right on, so that I can have it at the right distance up, and I'll do that on both sides. So, and then for the spark plug, I will flip it around like that. I'll still use this tooling hole. Come over here and dial that in, and I'll have my known dimension. Well, I know my dimension to the center line, but I'll know my dimension from this tooling ball over to the spark plug hole. So by putting two tooling holes in, it'll make the job, you know, really easy to do. So, because I don't know if I can draw a sketch, but I'll show you. I think I'll show you on CAD once I get everything laid out in CAD and ready to go. And plus, I made my head bolt studs. So I've got, this is the last one here. So that's done. Go like that, and then and then the head to go on there like that. I need to either make some acorn nuts or buy some. I don't like just a regular nut on it. I want an acorn nut on it. So I might just make those out of brass. I'd like to find some maybe I'll look on the internet, see if I can find some nickel-plated acorn nuts, 832s, and see what I can find. But the next step that I'm going to do before I do anything else is I'm going to take the cylinder heads and I'm going to mount them on my fixture block, my holding block, and I'm going to dial that in on the 4-jaw again, and I'm going to turn my cylinder head diameter, and I don't know if I want to put the grooves in yet or not. I think I'm going to wait. Maybe I'll wait and with the turning all together, because it'll make it a lot easier for when I'm putting the hole in. Yeah, I'm going to wait. So the next step will be to go ahead and put some tooling holes in here in the block. So I'm going to go and sit down with my CAD and go ahead and figure that out. And then when I get that, like I say, when I get this done, and then I'll give you like a CAD an overview of the. Well, I'll give you an overview of my drawing that I make from CAD using the tooling ball. So that's where I'm at. So it is starting to look. It is starting to look like pretty. I'm just doing all the external stuff right now. The internal organs or the internal stuff I haven't started on yet, so I'll have to make the flywheels, the crank pins that are mounted in flywheels, the connecting rods and piston and rings, and timing gear and lifters, but right now I'm just working on the outside stuff, and once I start working on the inside stuff, then that'll be on the final phase. So, yeah. So anyway, I'm going to go ahead and work on that next. So I'll come back when I get the CAD and everything all figured out.
Okay, so here's the drawing for my little holding fixture, and this is a tooling ball, and that'll go in right there, and there, in the opposite side, like that. And I sat down in my CAD and got to the dimensions. So when I drill that hole in, it'll just go straight in, and it'll be on the center line. It'll be on the center line of everything, and it'll be up or down from this top surface where the part locates, the cylinder head locates, 761 thousandths. Then once I do that, I can put the cylinder head on there, put the tooling coal in, or tooling ball in, and I can set it at my 21 degrees. Then I can dial in the center of that tooling ball. It'll be setting up like that, and I'll just sweep in the tooling ball, and I'll move over this dimension right here, 734, and it figures out to be 734 on both sides, intake and exhaust, and it's 21 degrees on both sides. And then my depths, I can set my cutter off the top of the tooling ball and subtract 250, because the tooling ball is a 1/2 inch diameter, and that'll put me on the center. Then I can just go down to these depths. So it'll get me the location, it'll get me the depths of the counter bores, and I should be set to go. And I have to remember though that there's a left and a right, which is the only thing I do is just switch the diameters around. I'll take this diameter, put it down here, this diameter, put it up there. But hopefully you understand where I'm going with this. So I need to go and take my block here and put my tooling holes in. It you know, it'll just put one right there, and actually they go all the way through, but I'm not going to drill them all the way through. I'm just going to drill and ream them. That way I know that the location will be good, and because otherwise if I drill all the way through, they could walk off a little bit. And they'd only have to be the depth of that of the tooling ball for it to slide in. So anyway, it's an easy way of getting your dimensions and getting them right where you want them. There's no guessing, and I see a lot sometimes drawings with a hole in a block at an angle, and they call out the breakout point, the point. You can't. How do you get there? How do you check that? You know, the guy I worked with at work was like that. He could not understand tooling holes, tooling balls concept at all, and I explained it to him over and over and over, and just couldn't get there with him. But anyway, that's another story in itself. But this will get me exactly where I want to be. Same thing with the spark plug hole. I'll be able to come down and mill that face, which is that, subtract the 250 for the tooling ball. I could have gave myself a dimension right to the top, but I gave it to the center line. And then the holes on center, and then plus up to 1 inch 436. So anyway, I'm going to go ahead and put the tooling holes in. And basically all I'm going to do is set it in the vise, pick up this edge, sweep this in, move back my dimension, and then pop the hole in, flip, same thing, flip, same thing, flip. I'm going to do it all 4 sides, and I'll be set to go then. And then I'll be able to come back and set up my 21 degrees, and we'll start putting holes in the cylinder heads. Because once I get it set up, all I have to do is I can do one, and then for the opposite one I just change different diameters and do that one without moving my fixture. So it should work out pretty good. So hopefully I explained it good enough. Sometimes I'm not very good at explaining things. Maybe that's why my partner at work didn't understand, because I didn't explain it right. But anyway, I'll come back when I start working on the cylinder head itself. So now we need to dial in the tooling ball. We put the tooling ball in there. I know the dimensions over. So we'll slide that tooling ball in there down tight. And now we'll scooch over there and okay. Here. Cat thinks it's supper time again. Apparently. Alright, so just eyeballing it now, just get it close, or try to get it close. Alright, so we're going to come down and we're going to touch on the ball and then lock the spindle. I'll just lock the spindle there and put it in for a 0 reading. And let's see, that's down, so that's high, and this is low, so it's got to go that way. Just touching there. Still bottoms out over there. Oh, right 10. All right. And there should be 15. All right. So we're 7 high there and 2 high there, so that's 5. So I'm going to move it 2.5 now. And I'll 0 it. 0. I'm going to put this on 0. It'd help if I unlock it. Just dragging. Alright. Let's 0 this. 0. 2 thou. I'm going to move it 1 thou. Right there. 0. 0. Move it a thou here. Alright, that should be dialed in now. Yep. So now we got the exact center of that ball dialed in. Now I know the dimension over, which is 734 thousandths. Oh, I didn't set my dial 0 on my dial, or 0 out my dial. I'll put the indicator back here before I do that. Forgot to 0 my dial. Just put this on 0, that way if I move it around, I can come back to it. Right there is 0. Because I got to be able to take the backlash out the right way. Oh. Just taking the backlash out. And we're going to 0 it. And now I'm going to go off mark and back to 0. Looks good. Alright. So, now we want to move over to that first hole. The exhaust port, which is 734 for both of them. So, once I get it set, it should be fine for both sides. So I'm going to go 734 thousandths over. Here we go. 1, 2, wrong way. I'm not going back this way, I want to go that way. 1, 2, 3, 4, 5, 6, and then 7. What did I say, 34? 34, so 10, 20, 30, and then 4, so I got to go back past and then take the backlash out. Right there. I'll lock that. Lock my Z, or my X and my Y. Get my cylinder head, my first one. And this is going to be the exhaust port, the big holes. So because one side has is smaller, and that I believe is the intake port. So it's going to go like that. It's snug. Alright, now I get some screws and hold that up there. These screws are long enough. Nope. I thought I had some screws laying out. I'll find some here. grab enough thread, I believe, to hold it there. Screwdriver. Tighten that up. Take that one up. A couple would probably hold it, but I'm going to put all four in just to make sure. I don't want it moving. There. And there. Okay. So, I didn't round up cutters for that yet. So, I'm going to have to round up some cutters for that, because it basically is going to be, I might even have to grind some up for that. But I'll still want to come back and touch off the top of the ball, come over and then down. What I should have did was milled a step or milled an angle with a known dimension from there up. I could still do that. Well, that's not going to help me anyway. I'll do it this way. So, what I need to do is round up some end mills. I'll have to round up some cutters. And, but it should be, let me just put a drill in there. Put a spot drill in and we'll see where it goes. It's going to go like that to intersect that hole. I could drill that first. I might do that. Drill that hole through first. Center drill. Can't use that spot drill. Well, I suppose I could have, but it's kind of an angle it really doesn't like. Turn my stop down. Turn my quill stop on the spindle down so I can get down there. Alright, here we go. Take my tooling ball out of there for a minute. I don't want to wreck my tooling ball. Alright. Just now I'm going to put I better check to make sure that I don't both like that. That is 3/8 diameter. That's supposed to be a 3/8 diameter. I'm going to go in there with a 1/4 inch here, spot drill, and hopefully drill it all the way through where it intersects. See you in there. Alright. Hopefully I didn't mess it up. And I want to go with a 3/8 now. And I want to go 1 inch, 142,000 feet. So, I know I'm not supposed to do this. Put an end mill in a drill chuck is a big no-no. Reason is, drills are soft up on the top. If this slides, it can mess up your jaws. So I'm gonna go here, and I'm just gonna try to eyeball it across. Do I really want to do that, or do I want to go ahead and actually set it? I think this should be close enough. Nope, I'm going to crank over there and get it close. Or I can get a piece of paper and in between and set that. Get back over to the hole. 1, 2, 3, 4, 5, 6, 7, 34. And now I want to go down 1 inch, 142. So what I'm going to do is I'm going to get I'm going to take an adjustable parallel and I'm going to set it at 1 inch, 142, put it in my quill stop. So basically, all I'm doing is just taking my calipers and 142, right there. And adjust my adjustable parallels to match it. Smaller. Come on. Alright, I'm going to get a little screwdriver, tighten them up. Tighten it up so that it doesn't move around. So now I've got a block here that I can put in my stop, my quill stop, my threaded quill stop on my spindle. Basically putting it in, turning it up tight. Now I take that out of there, now I can go down that dimension. So I should be able to shift into low. Take my tooling ball out of there. And hopefully go down through there. I do believe I messed up somewhere because... Oh! Yeah, I think I got this reversed. So that hole is supposed to go through the center of that.